Good morning, everyone. So today we are going to learn about the simplification of context-free grammar. Uh, Context-free grammar is the type 2 grammar. Context-free grammar is the type 2 grammar as per the Chomsky hierarchy. Grammar is defined as the combination of four elements V, T, P, and S, where V is the set of variables, T is the set of terminal symbols, that is small case letters, P is the set of production rules, and S is the starting symbol. Okay, and the rules are of the type of A generates alpha, where A is the single variable at the left hand side, and alpha is the combination of variable and terminal symbols. So your rules are of this type, like left hand side is the single variable, right hand side is the combination of variables and terminals, and S can also be there at the right hand side. Okay, so this is about the context free grammar. And for the grammar, when you see the grammar, it has a corresponding language, like here the language is A raised to n, B raised to n, where number of where we are saying that number of A's and number of B's should be same. And first all the A's are there, then all B's are there. This language is not a regular language because it does not follow pumping lemma, and it is a context free grammar, and we can visualize this sentences of the language with the help of a parse tree. Like here, the word of the language is AB. The word of the language can be also double A, double B, or triple A, triple B. Okay, so this can be viewed in the form of a parse tree, and you can write down the language ka grammar as S is equal to nothing but ASB. S is represented with the help of recursion, with the help of itself, and to stop the recursion we say S is equal to AB. Okay, and uh, the designers of context free grammar has the task in their hand to simplify the grammar. Sometimes in the grammar, in the BTPS of the grammar, there are many production rules which we can remove. Okay, even if that production rules are not there, the grammar is going to be the same grammar. So we have to identify the useless productions and remove them, and we have to identify the useless symbols. Symbols are the symbols from capital letters and small case letters. So symbols from capital B and capital T we need to identify and remove, and some production rules from P also we have to remove which are not usable. Okay, and we can simplify the grammar before its use. With the simplification of the grammar, your rules may go on changing. Like you may have only 5 rules in the initial grammar, but with the removal of this P, you may have 10 different production rules in your grammar. So your number of rules will increase when you simplify the grammar. Okay, then we have seen that in the simplification of the grammar, there are multiple steps. The steps are, first, you have to follow the steps in the particular sequence. Okay, don't forget, you have to follow the steps in a particular sequence. Like first, remove epsilon productions. So if there is any production such as A generates epsilon, then identify such productions and remove them. Second is remove unit productions. So suppose you have the rules like A generates capital B, then you identify such unit productions and remove them. Then the third one is to remove non-generating symbols, means the variables which are not deriving the terminal strings. Non-generating symbols, like the variables which are not deriving the terminal strings. And then you have to remove non-reachable symbols which are not reachable. Okay, so I'll teach you this with the help of example. Right now we are on the topic of removal of or simplifying the production rules. So I have given you the introduction about the null productions. That, like you have the rules such as A generates epsilon, remove them, or A generates bit B. So left hand side is a single variable, right hand side is a single variable, remove such unit productions. Okay. So you need to identify the null production rules and unit production rules and remove them. And that is the first two steps of simplification of the grammar. Okay, you cannot change the sequence. Like first you do remove the non-reachable, then null production, then it will not happen. You have to follow this particular sequence to simplify the context-free grammar. Okay, so first remove epsilon productions and then unit productions. So let's see what is epsilon production. Okay, this example we have seen here in the uh, given grammar. You have S, A, and B as three variables. S, A, and B are as three variable symbols. S is equal to A, B, A is equal to small a, capital B is equal to small b, capital B. Okay. So here identify the what are the steps, like identify the epsilon productions. So null productions means epsilon productions. So A is equal to null and B is equal to null, and your S is then now the remaining third variable is S. So try to check that whether S can also become a nullable variable. These are directly given productions. A is epsilon, B is epsilon is the directly given production rule. Now you have to check whether because of A and B being null or being epsilon, is there any other variable which can become also epsilon? So like this you need to find out. So try to check, if we see S is the third variable only and S is equal to ABA. So if both of them, A and B, both of them, they are epsilon at the same time, then S will also become epsilon. So we have identified the indirect null production. In the second step, first step you identify the direct null production rules. In the second step you identify indirect null production rules. So S is also nullable. So means now we can say that S, A, and B all three are nullable symbols. Means all three can be null or epsilon. Okay. So now start solving the problem. Rewrite the grammar without epsilon. So with A is equal to epsilon, B is equal to epsilon is not there. You rewrite them. Now these are the rules in your final answer. These are the rules. They are the part of the final answer. After that, you take the first rule. Like don't start from S. You always start from the second variable or last variable. So see, I'm taking the second variable. A is equal to epsilon. So I'm going to remove A is equal to epsilon now. But if I'm removing A is equal to epsilon, then you need to identify what are the changes or what are the different values of different other variables. So start from S, like start looking at here. You start from S. And if my A is epsilon, then suppose I say that this A is epsilon. So I'll say that S is equal to, here I'm taking this A is epsilon. So S is equal to AB. Now suppose this A is epsilon, then S is equal to BA. And if both of them they are epsilon, then it is equal to B. Okay. So if I'm removing A is equal to epsilon, then my S can also be AB or BA or B. That is the meaning of this particular step. Now take the second rule, and here suppose A is epsilon, then your capital A can be small a only. Okay. And for this particular rule there is no A, so no change. So now we are done with this all these three variables for A is equal to epsilon. Now take B is equal to epsilon from here. So take B is equal to epsilon, start from here from the first rule. If B is epsilon, then S will become AA. Okay, so this is done now. Now for A, here there is no capital B, so there is no change. Here there is a capital B, so your B can also be a small b. Now go to the next rule. Now here if your B is epsilon, then S can become capital A. So I'll say S is equal. Now see here the change is that for A is equal to epsilon, we have done only with these three variables. Now with B is equal to epsilon, we have to do with all this 3 plus 4, all the rules we have to check. So here we are checking if B is epsilon, then S will become A. Now in the second rule also, if this B is epsilon, the S is equal to A, but which is already written down. And then S is equal to capital B, so here too we cannot say this S will become epsilon, which we are considering here as a nullable symbol. So we are not going to do anything with this rule. Okay, and then A is equal to small a, also there is no change. Now take the third, S is equal to epsilon. Now if S is equal to epsilon, start from here. There is no S here, so no change. There is no S here in the right hand side. There is no S here in this all four, in all these three. Now for S we have to check for all these three rules plus A ka 4 rules modified and B ka 3 modified rules. In everywhere there is no S in the right hand side. So if there is no S in the right hand side, there is no change in this rules. So this is the final set, which is the answer. Okay. So you can combine them together and write it properly in the final answer. That S is equal to ABA and then capital AB, then capital BA or a capital B or capital AA or capital A. Or A can be small a capital A or small a, and capital B is equal to small b capital B or small b. Okay, like this you have to rewrite the final answer. So overall understand for the identifying null production rules, you first identify the direct null production rules which are given in the grammar, and because both of them they are epsilon, identify what are the other variables in the grammar they may become epsilon, and then you write down the nullable symbols, all the nullable symbols together. Start from, don't start from s always, you start from the second variable, and for all the variables you keep on adding the new rules and rewriting the grammar, and then at the end you try for the starting symbol, and then combine all the rules together, remove the duplicate which you have got, and rewrite it, and that is the final answer. Okay, so we have seen this particular example. Also we have seen this example last time. So now, so now I'm going to teach you about the new topic, that is removal of unit production rules. Okay, so I'm teaching you something new, which is removal of unit production rules. Like the rules are of the type of A is equal to B. That means left hand side is a single variable and right hand side is a single variable. So suppose you observe this particular rule, A is equal to B, like A generates B. So what is the meaning of that? If you see here, we are saying that A is nothing but else, nothing but B. Okay, what we are saying is that A is nothing but B. That means whatever is in B is equal to A. Okay, if you interpret it like this and if you remember this, then it is not a problem to solve this particular question. What we are saying is that we have to remove the unit production, such as left hand side is a single variable, right hand side is a single variable, and A generates B. What is the meaning of that? We are saying that whatever is there in B, what is the value of B, is also A. So A is nothing but B. So that way you interpret it and then rewrite the grammar. Okay, so let's take one example. Suppose you have to remove the unit productions from this given grammar. Okay, and likewise it is just an example. Okay, it can be a different variable. So this is the given grammar that is given to you, and now you have to remove the unit productions. Okay, so the first step is to identify what are the unit productions. So just check it here. Here S is equal to capital B is a unit production. S is equal to B and S is equal to A. These are two unit productions. For here there is no unit production. For A and B also there is no unit production. Now you rewrite the grammar. Okay. So how to rewrite the grammar? We say that you take for the first rule, that S is equal to B. So what do you have to say, that S is nothing but B. So how to rewrite it? Uh, First you write it without the unit productions. First you write the grammar without unit productions. I'm writing it here, ABA, AB, capital BA and double A here as the first rule. And the B as other rules are remaining same. So this is the part of, these rules are the part of the final answer of removal of unit productions. So these rules are there. Now you identify the unit productions. So S is equal to capital B. Take the first unit productions. Okay, here it is not null. Here it is. This is not null. null, it is unit. Okay, and this is also unit production. So this is not null, this is unit production, this is also unit production. Okay, so remember this. Now I am finding the first unit production, that is S is equal to capital B. So take S is equal to capital B. So that means S is nothing but capital B. So what are the rules which can be there for S? That S, whatever is there in B is also is equal to S. So you say S is equal to small b capital B. Okay, so this is the change that we have done. Okay, so this is very easy step. Then in the second unit production, you have S is equal to capital A. So what is the meaning of this rule? S is nothing but A. Whatever is there in A is equal to S. So A is equal to small a capital A, and or A is equal to small a. So S can also be here small a capital A or A. Okay, so we'll say S is equal to small a capital A or A, and then rewrite the grammar. So when you rewrite the grammar, you combine, like write the final answer, you combine all the rules. S ka all the rules, then यहाँ पे S ka rules, and the third is S ka rules. So write, combine them together, write the visible, properly visible final answer. Okay. So have you understood this? Removal of unit production means just a simple step. Identify the unit productions, and then if it is A is equal to B, then the meaning is that A is nothing but B. So what is there in B is also equal to A. So remove this in my final answer. I've removed the unit productions. There are no unit productions, but my number of rules are increased. Okay, so solve the next problem. That removal of unit productions. S is equal to capital A small b, A is equal to small a b c b, and B is equal to A and double B. Okay, so identify the unit productions. See, there are three unit productions now. S is equal to B, A is equal to B, and B is equal to A. Okay, so now you write down the grammar without unit productions. So this is the grammar without unit productions. Take the first unit production rule. Okay, so I'm suggesting you that for solving this particular problem, you start from the last variable, and this last variable, and then go up. Like take first B, if there is any unit production of for B, then A, and then S, and then it is not a confusion. Okay, so I'll take B is equal to A. Okay. So now for B is equal to A, B is nothing but A. So what I'll say that B is equal to small a capital BC also. Okay. So I've written down whatever is there in A as a B. Okay. Now take the second variable A के लिए A generates B is the rule. So A is nothing but B. So now here A is nothing but B. So whatever is there in B is also A. So write down that. Okay, now then S is equal to B. Okay. For S is equal to B, now you say S is equal to B, so B is equal to double B. So S is equal to double B, but here it is double B, and then you need to consider all. Whenever you are considering S, you need to consider all the rules till till this particular state. So B is equal to double B, B is equal to small a, B C is also there. So S is equal to double B, small a, B C, and here there is no S. Okay. So here you need to remember, like this particular step is very, very important. Here also, for A is equal to B, we say that A is nothing but B. So we'll say A is equal to double B and A or BC. But A or BC is already there. So that's why I am not writing it here. But I can write it here also, and I can remove the duplicates when I write the final answer. Okay. So A is equal to B means A is nothing but B. Whatever is there in B is also A. So this plus this. So it is A is equal to BB or A or BC. But A or BC is already with A. So I have not written down here. And like this for S is equal to B, S is nothing but B. So S is equal to double B and S is equal to A or BC. And then now you combine everything. So S is equal to this small a capital A, double B, A or BC. And then rewrite the answer. Okay, now let's see the second problem. Now this is a little big problem. Okay, you now you can start solving on your own, and when you are solving, that time you may get some problem. That time you can also refer and listen to me and see. Or as I'm solving, you also try to solve on your own. Okay, and at the same time you listen and uh, do it properly. Okay, so removal of unit productions. Identify the unit productions. I can identify. I start identifying from the last variable. So I here there is no production, unit production. In the second here F is equal to I. So I have written down F is equal to I. Then T is equal to F is also a unit production. E is equal to T is also a unit production. Okay, so there are three unit productions. Now you write the grammar without unit productions. So in the next step, write down the grammar without unit production. These are the rules which are there, which are the part of the final answer. Now you take the first rule here from here. If you start from this F, so take F and add the new rules. So if I say F is equal to I, that means F is nothing but I. So whatever is there in I is equal to F. So I'll rewrite F. So F is equal to I. So I've written down F is equal to I. Okay, now you take so this is done. Now you take the next one. Next one is T is equal to F. So T is equal to F means T is nothing but F. Okay, so T is nothing but F. F is equal to this E in the brackets. So I'll say that T is equal to that bracket plus F is nothing but this also. So F is equal to this bracket ka original rule and all these rules which are newly added. So combine everything together and assign it to T. So T is so that's why you have to start from the last variable when you solve. You can also solve from E, but then you will have to keep on doing this in multiple passes. It will not happen in the one pass. So so start from the last variable and then the first variable. So this is nothing but actually S, capital S जैसा ही है ये. So T is equal to F, but F is all these 3 plus 3 6 rules and this original rule that is all 7 rules. So T has modified now and T is equal to these many rules of F. Now take the first one that is E is equal to T. So E is equal to T means E is nothing but T. So this is so start writing that E is equal to T. T is equal to T into F. So write E is equal to T into F and all these rules of T. So I'm writing here E is equal to T into F and whatever is the value of T here. Everything is added. So finally now it is the answer is complete. So combine all the rules properly. You say E is equal to E plus T or all these rules. Then T is equal to T into F and all these rules. F is equal to capital E and all the rules. And I will remain same. Okay. So combine them together and rewrite the answer. Okay, so this is done. Now solve the next problem. Okay, this is the problem of removal of null productions. Removal of null productions, so again the first problem, removal of null productions. Okay, so actually there is no animation done here. I'll do the animation. Okay, here we have to you can start solving this problem. Write down this problem in your notebook. S is equal to all the rules for S, A, B, C, D. Okay, and you need to. The problem is that you need to remove the epsilon productions. Okay, so see this problem of there are total 5 rules, and the problem is to remove epsilon productions. So the first step is to identify the epsilon productions. There are two epsilon productions. C and D are two epsilon productions. C is equal to epsilon and D is equal to epsilon. After that, you need to identify that whether, because C and D both are epsilon, is there any other variable which is also epsilon? So tell me your answer. Is there any other nullable symbol? Write down your answer in the chat box. Because C and D are already nullable, try to check whether S is nullable, A is nullable, and B is a nullable. Write down your answer in the chat box. Which is a nullable symbol? Yes, yes. Oh, yeah, you have shared me the whiteboard. This also I have tried, but it also takes time. This also takes time to write down, and it's not comfortable. That much comfortable. Okay. Capital A is the correct answer. Now in this capital A, so capital A is also a nullable symbol. So A is also becoming, because A is equal to CD, and if both C and D both are null symbols, then your A is also becoming a null. So only A is nullable out of three, S, A, and B. So total I have three variables, C, D, and A as a nullable symbols. So now rewrite the grammar without null symbols. So like this here you write down. Now you have to take the first C is equal to epsilon. For C is equal to epsilon, what are the changes? Okay, so now start from here. S. So S is equal to here first C is epsilon. So AB and BC, DA. Okay, so I'm writing, I'm assuming this as epsilon, so it is AB, BC, DA. Now I'm assuming this C as epsilon. So it will be ABCBDA. Now I say both of them they are epsilon at the same time. So it will be ABBCA. Okay, ABBDA. Okay, because the C is not there. So because of this, the single rule got changed into three different rules because C was there for two times. So so there is a possibility that left hand side C is only epsilon, and or only right hand side is epsilon, or both of them they are epsilon. Okay, so three possible combinations. Now you go to the next rule here. If C is epsilon, then your A will become D. Then go to the next rule. Here if C is epsilon, B will become small b. Here there is no change, and here is also there is no change. So C के लिए we have done with this. Now take the next one, that is D is equal to epsilon. So take the next one, D is equal to epsilon. Start from the first rule of your language. So D is epsilon, so your S will become ABC, BCA. Then here D is epsilon, so A will become C. Then here there is no change, no change, and capital D will become small b. Okay, so this now you go here. Okay, don't forget, don't stop here. You have to go here because now this your language is modified and this many rules are there in the language. Now here, if this D is not there, then S will become AB, BCA. Then if this D is not there, then S will become ABC, BA. Then this D is not there, so it will become ABBA. Then this no change, no change. And now stop. Okay. Now take the third one, that is A is equal to epsilon. For A is equal to epsilon, now start from the first rule. So this A is epsilon, so S will become BC, BC, DA. Now this A is epsilon, so it will be A, B, C, B, C, D. Now both of them they are epsilon, so it will be B, C, B, C, D. Okay. Now go to the next rule here. A is epsilon, no change. 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 But here again, there is A. Okay, so S will become double B, C, D, A. If the left hand side A is epsilon. If the right hand side A is epsilon now, then it will become A double B, C, D. Okay. And now if both the A's are epsilon, then S will become double B, C, D. Okay, so for this particular rule, because A is epsilon, there are three more added rules in the grammar. Okay, now next, take the next one. In the next one, left hand side A is again epsilon, so you are getting BCBDA. Right hand side variable is epsilon, so it is ABCBD. Both are epsilon, so BCBD. Now here A is epsilon, no change. A is epsilon, no change. Now here, if A is epsilon, it is BCBCA. Um, A is epsilon, then it is. I think I forgot something. Now this one. This is the third rule. So it is this A is not there, so it is double BDA. Then this A is not there, so it is A double BD. And if both are not there, then it is double BD. Okay, now this go ahead and take the next one. So here S is equal to BCBCA or S is equal to ABCBC or S is equal to BCBC. Then here also there is no A. Here A is there. So S is equal to double BCA or S is equal to A double BC or S is equal to double BC. Okay, so three rules. Here also there are three rules will be added. A is equal to BCBA, A is equal to AB, CB or S is equal to BCB. And then for the last rule, A double B A, S will be equal to double B A or A double B or it is B double B. And now here you have to stop. Okay, so these are many rules are there. Now to write the final answer, you combine all the rules. So combine all the rules of S together. But here there you may find out some of the duplicates. If there are any duplicates, then remove the duplicates and then write down the answer. Okay, but I don't think there is any duplicate here. Okay, so let's see now about removal of useless symbols. Okay, so see, useless symbols, there are two types of useless symbols. Non-generating useless symbols. Okay, is there any doubt in this? Now we have studied about removal of epsilon productions and removal of unit productions. Okay, means we have learned about removal of P. Now the symbols are there in the V and symbols are there in the T, capital T. So we are going to learn about removal of symbols from V and T. Okay, so that is called as removal of useless symbols. Okay, now there are two types of useless symbols: non-generating useless symbols and non-reachable reachable symbols. So non-generating symbols are the symbols which is mm, j- which cannot be generated. Means that a generating symbol is a symbol which can be generated from the starting symbol S. Okay, if you start from S, the generating symbol is going to be generated by following multiple steps. So they belong to capital T. They belong to capital T. These non-generating symbols, they belong generating symbols belong to capital T. So from capital T, the symbols which are useless and which are not not generating anything, mm, the symbols which are not generating any terminal symbol is called as a generating symbol. Okay, I'll just repeat this again. The non-generating symbols belong to capital V. See here, remember, non-generating symbols belongs to capital V. Means it is a variable. It is a capital letter. And how to identify it? Just remember the definition of generating symbols. Any symbol from capital V who is generating the symbol or string is called as a generating symbol. Okay. I think I'm making it complicated. I'm just repeating again. Non-generating symbols and generating symbols, they belong to capital V. They are capital letters. Generating symbols from V are the generating symbols who are generating the strings of the language. Who are generating the strings of the language, means the words of the language. So the variables who are generating the words of the language are called as generating symbols, and the remaining symbols will be non-generating. Okay, so what we assume, what are the rules here? We need to remember that every symbol in capital T is generating. Okay, start from that. Like in the minimization of DFA, we had to find out non-reachable symbols. So similar to that, we assume that all the symbols of capital T are generating. So small ab are generating. So if there is any production rule who is generating A or B is also generating. Okay, and like this you can go on adding the symbols in the generating set and repeat the process. And after that, whenever you have to stop, the symbols which are there in this set are the generating symbols, and the remaining symbols are non-generating. Okay, so let's quickly revise this. Generating and non-generating symbols are the symbols belonging to capital V. Means in this particular step, we are going to remove the symbols from capital V. Okay. To remove the symbols from capital V, we have to identify first all generating symbols. So how to do that? We say that capital T contains the strings symbols which are used in formation of the string of the language. So we assume that a symbol A and symbol B is a generating symbol. Okay. Then identify any capital letter who generates this A or B or the combination of A's and B's. So that variable will also become the part of the generating set. Then you have multiple symbols here, A, B, and some variable. So for all of these three, you identify any other variable who generates any one of this, any combination of this. Like this, you can go on adding variables in the generating set. And whenever you stop, whatever is there in this set are the generating symbols, and all other are non-generating. Okay. So we'll solve the problem, and with the help of problem also we will understand. Then non-reachable symbols are the symbols which are not reachable from S directly or indirectly. Non-reachable symbols are not reachable from S directly or indirectly. So how to do that, or how to identify that? You need to plot a graph by putting the nodes of all the variables and then try to join them their edges. Okay, and if everything is connected, whatever is disconnected is non-reachable. So first we will start with this particular problem. Suppose this is the grammar given to you. There are four different rules. S is equal to small ac or sb. A is equal to this. These are all capitals. This C is capital, S and B capital, SC capital, SB capital, BC capital, and BC capital. So you have this particular grammar. Now, first you have to remove. The question is to remove the useless symbols. So assume that what are the generating symbols for the first step. So I say that the generating symbols are small a, b, and small d. Here d is also there. So my small a is the small case letters. All small case letters are terminal symbols. So I say that small case letter is a generating symbol. Then small b is a generating symbol, and then small d is a generating symbol. So I start from this set, generating symbols ka set. A, B, D are generating. Now try to find out who is generating A, B, D by these four variables. So here it is generating AC, but all the ABD is not there. Here it is SB. So ABD is not there. So we don't consider this. Now here ASCA. So this is also having SC variable which are not in this set. So we cannot do anything. A is equal to ASB. SB not there in the set. B is equal to BC. BC is not there in the set. Then C is equal to ABC. BC is not there in the set. But C is equal to AD. So here C is equal to small ad. This rule A and D both are there in this particular set. Both are there in this particular set. So we say that C, A and D were already generating symbols. Now C is also a generating symbol. So we add C in this set. Now your set has become the set of four elements. That is capital C and ABD. Now again start visiting all the rules. So here you see A and C. A and C, A and C both are there in this set. A is also there and capital C is also there. So at least one rule should be there. So because of this, S has become a generating symbol. So we have modified, updated the generating symbols ka set. Now S is added here. Now we have all five. Okay. So start from S is already added. So start from A now. Now your A is equal to ASCA. Now check S and C both are there. A is also there. So A, because ASCA के rule की वजह से now A has also become a generating symbol. So now add A also in this set. Okay. And now we have all this ASC, ABD. So A is done, S is done, C is done. Now B. For B we have to check. So B is equal to ASB. All the symbols of this rule A, S, and B, all three of them are not there in the set. So B cannot be added here because of this rule. Check the another rule. Small b is there, capital C is there, but capital B is not there. So this is also we cannot add. Okay. And now all the variables are over. So A is added, S is added, C is added, but B we cannot add because nothing is there in the rule. We cannot do anything about it. And now we say that B is a non-generating symbol. So if we identify any non-generating symbol from the grammar, simply remove B here. Remove B and remove all the rules which are there with B. So remove this SB, remove this B, all the rules, and remove even this rule. And your grammar is simplified. Okay. After this, now you have to take the check for the non-reachable symbol. So this is your set. A, S, and C come. So what you do, you start drawing the nodes. So first you draw S variables, S, then A and C. So here we are looking only for A, S, and C. And now even look at the rules also. When you are drawing this diagram, look at the rules also. So here S, A, and C is drawn. First you draw only the nodes. Now check for the variable. S is equal to AC. Okay, because of S is equal to AC, now you reach from S to C. So C to reachable हो गया. Okay. Second rule is removed from the grammar. Now you have A is equal to SC. So for A is equal to SC. So uh, because of this S is there here in the rule. So through A you can reach to S. Even C is there. So through that rule you can reach to C also. Okay. So from A you can reach to S as well as from C because of this rule. Now take this is removed from the grammar B. Now take C. This is also removed. C is equal to AD. So C is equal to AD, there is no variable. So we cannot say anything. Like from C, you cannot reach anywhere else to any other variable. So now if you observe this particular directed graph, S is S from S is a starting symbol. From S you can reach to C, but from C you cannot go anywhere, and even from S you cannot reach to A. So A is non-reachable. See, from to A there is no incoming transition. So A is non-reachable. Okay. So we have identified A is also useless. So B is useless, A is useless. So if both of them they are useless, now again remove A also. Capital A curve is also. And check wherever there is any capital A. Remove that also. So if you remove A and B, then finally your answer will be S is equal to small a capital C and C is equal to small a d. And A and B are removed from the grammar. Okay. So remember this, like for removal of useless symbols, we have to remove the generating symbols, non-generating symbols first, and non-reachable symbols. And both the symbols are from the set capital V. Both the symbols are from capital V. Okay. So first assume that all the symbols of capital T are generating symbols, and then any variable who is generating any one of those terminal symbols or group of them or uh, is also generating. Like this, you keep on adding the variables in the generating set, and uh, when uh, uh, when you have to stop by with the condition, you identify non-generating symbols. Remove that particular symbol from everywhere and you get the resulting grammar. See the resulting grammar. For the resulting grammar is the input to the non-reaching symbols, and for the resulting grammar you try to draw the directed acyclic graph. And from the graph you come to know whichever the symbol is the non-reachable symbol. So identify that and remove that also, and then rewrite this grammar. Okay, this way you can do this step. Okay, so for just to summarize, for simplification there are four steps: removal of epsilon, removal of unit, and then removal of useless symbols. And there are two types of useless symbols: non-generating and non-reachable. Okay, and you have to do all these steps together one by one, and then your grammar is simplified. Okay, and simplification is the first step for other problems of context free grammar. So you need to practice simplification. Okay, today I'll upload the tutorial for CFG. You solve this tutorial of simplification. Okay, so that the rest of the topics you will be able to understand. Okay, so as the time is over, we'll stop it for today. So have a nice day.